Prove that a line drawn parallel to one side of a triangle to intersect the other two sides in distinct points divides the other two sides in the same ratio. Actually, this is BPT, basic proportionality theorem. We have to prove it first. Basic proportionality theorem. Here if we will see, ABC is a triangle and we draw a parallel line DE which is parallel to BC. Now we have to prove that if we draw a parallel line to a particular side of the triangle, then it divides other two sides in the same proportion. That means if D is parallel to BC, we will get AD, you see here, AD by BD is equal to AE by CE. This you have to prove. Before going to prove it, we have to recall which we have studied in the class 9. If there are two parallel lines, suppose this is a parallel line, these two are parallel lines. This is a line, first line, this suppose it is AB, and another parallel line we draw with it. Another line to parallel to it is CD. And suppose these 2 points we are taking as E and F. Then if we draw a triangle between two parallel lines having the same base, suppose this is a triangle having, suppose EFG is a triangle. So another triangle we draw in this way, that is EFH, then they will have same area. That means area of EFG is equal to the area of EFH. If we draw two triangles between two parallel lines having the same base, here the base is EF having the same base, for both the triangles base is same here EF, then they will have same area. Now from this concept we will write that area of BED will be equal to the area of CDE. You see here the two parallel lines are D and BC and both having the same base. Suppose if we will see D is the base, then D is the base of both the BDE triangle and DCE triangle. They will have the same base. So the area will be same. Now we can write, if we will write the area of ADE by area of BED, that will be same as area of ADE divided by area of CDE. That we can write. Okay, because BED area is equal to CD area and AD in the numerator are same, so this is a valid equation. Now area of ADE, now you just put the values. Area of ADE, we can write it as half into AD into QE divided by area of BED. If you will see, area of BED will be equal to half BD into QE. That is same as, again area of AD we can write as half, if base we take as AE, then into PD or DP, because we have drawn the perpendicular here, where EQ is perpendicular to AD and DP is perpendicular to AE, divided by half into it is CE into DP. If you will see, DP cancelled out, QE cancelled out, half also cancelled out, and we will find, you see, AD by BD is equal to AE by CE. This is proved. Now we have to apply this formula over here. Here if you will see the first case, I just separated it. This figure I have separated. Also we can, you see, ALM triangle. The first case, suppose you will see triangle ALM and triangle ABC. If you will see here, LM is parallel to BC, so we can write AM by BM is equal to AL by LC. Similarly, in triangle ALN, in the second case, ALN, and in triangle ACD, we can write AN by DN is equal to AL by CL or LC. Same thing, LC. Now, from these two equations, this is equation 1, this is equation 2. From equation 1 and equation 2, we will get AL by LC is equal to, that is AM by BM is equal to AL by LC, that is same as AN by DN. Or we can write this as AM by BM is equal to AN by DN. And this question, it is write AM by MB, or that is we can write BM as MB also. AM by MB is equal to AN by ND. AN by ND. This was we have to prove.